Okay, so we've talked about these ratios, and there are a couple other ratio examples I want to look at. But before we do that, there's a couple things on my math lab I want to take a peek at. If this will log in relatively quickly for us, at least. One thing that was just pointed out, or was just brought up here, that I would like to point out. Yeah, if you're going through any of the problems here, the quizzes don't do it, but the homework will. If you're going through one of the homework questions and you're having problems with it. So let's say you're doing this question and you're not really sure how to do it. Now you can go through all the helps here. They help me solve this, view an example. If you click on textbook, it'll actually take you to the section in the textbook even. Actually, not even the section, the page in the textbook that discusses that topic. Yeah, they can hear me. It takes a while to load, but here it takes you right to the page. The section, usually it's right the exact page or the section that covers that topic. So we can see here, this topic is from section 3.4. But even further than that, if we look up here in the corner right here, this says 3.4.63. What that is telling me is if I open up my textbook, 3.4.63, the 3 is telling me that that is chapter 3. The 4 is telling me that is section 4. So in other words, this is in section 3.4, the fourth section of chapter 3. The 63 then is telling me that is question number 63 at the end of that section. So if you go to chapter 3, section 4, to the end of that section, question 63 should be nearly identical to that question in my math lab that we were looking at. So there's just an extra way, you have the help me solve this and view an example will allow you to see two versions of the problem, actually even a third version if you ask for a similar question. This gives you a fourth version you can look at right out of the textbook. And of course, since for homework I give you odd numbered problems, if you look in the textbook, all the answers to the odd numbered problems are in the back of the book. So that might help you figure out how to do the one in the textbook, which might help you figure out how to do the one in my math lab. The quizzes work the same way, but usually you give you even numbered questions on the quizzes, so the answers aren't in the back of the book.
Does it give you that on the quizzes too?
I'm not sure if it actually displays it or not, but I made sure I selected even numbered questions on the quizzes anyway, just to be sure. Just to be evil. Ouch. Wow. Okay. Another thing that came up is something like this. X to the fourth to the power of 0. What's that going to equal?
0.
What's that going to equal? 1. There we go. The reason for that, remember, we went over this a little bit a couple classes ago. Anything to the power of 0 has to be 1. If I have 8 to the power of 3, it's 512. 8 to the power of 2 is 64. 8 to the power of 1 is just 8. When I look at this, if I'm keeping a base on my exponent of 8, if the power goes down by 1, the result over here is divided by 8. I go from 2 down to 1. This is divided by 8. 64 divided by 8 is 8. If I keep going then, 8 to the power of 0, this has to be divided by 8 again. Well, 8 divided by 8 is 1. Now we mentioned briefly, if we kept going, 8 to the power of negative 1, what's 1 divided by 8? 1/8. And 8 to the negative 2 would be 1/64. So 8 to the power of 0 is 1. And I can go to any other number. I could put in 5 if I wanted to. 5 to the power of 3 is 125. 5 to the power of 2 is 25. 5 to the first power is 5. Again, we see I reduced the power by 1. This time the number is divided by 5 each time. Reduce that by 1, divided by 5. So if I reduce it by 1 again down to 5 to the 0, I have to divide this by 5, which will give me 1. Anything to the power of 0 is 1. So if I were to be a little twisted, okay, I am a little twisted. If I decided I wanted to live dangerously on a test or a quiz somewhere, I could give you a problem like this.
One.
There you go. That's 1. Because it's all to the power of 0, it has to equal 1. Doesn't matter. None of the rest of this matters. It's all to the power of 0.
Thank God.
I have done that on quizzes before, but I probably won't do it to you guys.
Yeah, why? That's the only one.
That's the only one you'd get right now. What's that? Well, if you see the trick, they're nice. If you don't see the trick, they're frustrating. Okay. So we left off talking about ratios and rates. Ratio, or a couple of examples more that I want to show you before we move on. I want to look at probably one of the biggest ratios in most people's lives when they go to the comparison shopping. Where's that true? I was thinking of going for credit and going to make a loan for a car or a house or whatever. Your bank looks at the debt to income ratio. The way your debt to income ratio goes is it looks at your monthly debt payments to your monthly income. So let's say you have a monthly income of $3,200. That's before taxes, before any deductions out of your paycheck. That's your gross monthly income, $3,200. Say for debt payments, you have a mortgage on your house. Now this does not include the taxes that are escrowed in your mortgage or the insurance that's escrowed in your mortgage. So this is going to seem like kind of a low mortgage number. But let's say that your mortgage is $525. Yours is lower? Oh, good. You did something right. Let's say that you have monthly credit cards that average, let's say, $275. By the way, I tend to use my credit cards for everything. I don't pay cash. I don't write a whole lot of checks anymore. In the end of every month, I pay them off completely. There's a slight problem with that. Even though I'm not using it as credit, I am still making a credit card payment, and that is a debt payment. So let's say that I have, buy groceries, gas, supplies, whatever. Let's say that comes to $800 a month. That counts against, the bank looks at that and sees that as an $800 a month debt payment, even though I'm not carrying a balance. This $275 here, it doesn't matter whether you're just buying $275 worth of stuff every month and paying it off, or if you have $10,000 worth of debt sitting out there and $275 is your minimum monthly payment, the bank's going to see that the same way. Just a little forewarning. So anyways, we're saying you want a car, and your proposed car payment is going to be $400. So now as we look at this, your total proposed debt is going to be $1,200. 525 plus 275 plus 400. So that would make your debt to income ratio $1,200 over $3,200. Now I didn't put the dollar signs on there because they're going to cancel out. I can divide by 100 to make it 12 over 32. I can still divide by 4 to make that 3/8. Now, they want your debt to income ratio to be less than 1 out of 3, 1 to 3. To compare that to the 3/8, I'm going to do this. I multiplied by 3 on top and bottom. That'd be 3 to 9. Looking at ratios here, this is saying I'm allowed to have 3 units of debt for every 9 units of income. Does that make sense? This is saying I have 3 units of debt for every 8 units of income. Is that acceptable? No. I have the same debt, but I have less income. So the bank would most likely look at this and say, no, you cannot afford a $400 car payment because it puts you over that 3 to 9. To have 3 units of debt payment, you must have at least 9 units of income, and you only have 8 units. You do not have enough income for that debt payment. Just a little insight into how our ratios work. Okay. The next topic, the next step in doing these debt to income, or these ratios and rates, is to figure out, okay, what am I allowed to have? So let's say I want a ratio of 2 to 5. Let's say it's a gear ratio, so that my driving gear has 5 teeth for every 2 teeth on the driven gear. Let's say I have a motor that has 35 teeth on it. First of all, is that 35 going to go on top or bottom? It goes on bottom because what's attached to the motor is the driven or the driving gear. So the 35 goes here. So in order to maintain that 2 to 5 gear ratio, I need to know what number I need to have up here on the other gear, how many teeth on the other gear, to have the same ratio. Now there's 2 ways I can do this. I can just look at this as equivalent fractions and I can say, hey, what do I multiply 5 by to get it to 35? 7. So I'm going to do the same to the 2. 2 times 7 is 14. But it's not always quite that simple. Let's say I have a rate where on a 400 and, let's see here. Trying to make one that's not terribly complex. So on a 450 mile trip, I use, make this somewhat reasonable, 12 gallons of gas. I want to know how much gas would I have to use, or how much gas would I need to go on a 600 mile trip. So this is a rate here, 450 miles per 12 gallons. It's not a unit rate, it's not reduced, but it doesn't matter. I'm using that to compare, assuming that rate stays the same, how much gas would it take to go on a 600 mile trip. Now, one thing you'll notice here, in these are what we call proportions. And a proportion is really just 2 fractions that are equal to each other. Those fractions can either both be rates or both be ratios. But in our proportions, things match up. The teeth in the driven gear was here. The teeth in the driven gear was on top on the other side as well. Teeth in the driving gear, teeth in the driving gear. Here, miles are on top, miles are on top. Gallons on bottom, gallons are going to go on bottom. To find this missing number here, trying to say what do I multiply 450 by to get 600 isn't terribly practical. So there's another process we can use. It's called cross multiply. And it comes from solving equations. If I were looking at solving this equation, well, if I were looking at solving any equation like this, that's D, by the way, not another A. If I wanted to get A by itself, what would I do? I'd multiply by B, right? That'd give me A equals C times B over D. I could also multiply by d to get rid of the d over here. That'll give me a times d equals c times b. Now, you may not necessarily understand what I just did here with the symbols, but that's okay. What this is saying is, if I have a ratio like this, a over b equals c over d. A times d, which is the two numbers on that diagonal, has to equal c times b, which are the two numbers on this diagonal. If you look at any ratio or any equivalent fractions we've ever worked with, that'll be true. 3/4 equals 9/12, correct? If I cross multiply, what is 4 times 9? 36. What's 3 times 12? 36. 2/5 is equal to 6 out of 15, correct? If I cross multiply, 5 times 6 is 30. 2 times 15 is 30. Those cross products, they're called the diagonal products, have to be equal. So up here, if I put an x right there, if I multiply this way, 12 times 600 is 7,200. 450 times x is 450x. Those have to be equal. 7,200 has to equal 450x. So I am going to divide 7,200 by 450, which is going to give me 16. X equals 16. So that's telling me that I need 16 gallons to go 600 miles. What's that? How'd you divided it out to get a unit rate?
Yep.
You divided 450 divided by 12. Okay.
Yep.
You're basically doing that here. It's just a shortcut so you don't have to go through all the steps. Okay, let me do a couple simpler examples. Let's say I have a 5:8 ratio. And over here, I want to know how much that would be out of 28. So I'm going to put x in here, and I'm going to cross multiply. Again, I multiply on the diagonals. 5 times 28 is 140. 8 times x is 8x. Now those two have to be equal. 8x has to equal 140. So what am I going to do? 5 by 8. Yep, that's exactly right. 17.5. Sure you can. We just did. So if it's a 5:8 ratio, that would be 17.5 to 28. It is okay to have a decimal or a fraction within a ratio.
So you can just take and multiply those two and then divide by that one.
That's where we're going next.
Okay.
You beat me to it. You beat me to it.
It's like you're doing all this extra stuff. It's like teaching math to the kids nowadays.
What's that?
It's like
No, the answer is the 17. X is 17.5. But they said you beat me to it. There is a shortcut here.
Okay.
If I have, let's say I have 5:6, a 5-to-6 ratio, and over here this number is 35. Now I know what x is. Rather than cross multiply, I cross multiply 6 times 35 is 210. 5 times x is 5x. And I could write my equation. 5x equals 210. But the first thing I'm going to do to solve this is divide by 5. So x equals 42. What I could do is right here in the proportion, instead of cross multiplying, I could do a shortcut. I could say, hey, I'm going to multiply 6 times 35 are on a diagonal. So I'm going to take that diagonal that has both numbers, and I'm going to multiply it. 6 times 35 is 210. But rather than multiplying the other diagonal, since there's a variable here, I just say, well, that's going to be 5x, and I'm going to divide by 5 to solve it. So I'm just going to divide by 5. Gives me 42. X is 42. That process is actually called cross multiply and divide. Actually, a name in math that makes sense, huh? So let's say we have a ratio of 4 to 3, and I want to match that up with a ratio of 34 to x. To find x, what am I going to multiply? 3 times 34, which is going to give us 102. And then I'm going to divide by the 4, which is going to give me 25.5. So the question is, if we can just cross multiply and divide, why did I bother showing you the full cross multiplication? It's not just because I'm mean and I want to make life difficult on you. Because this only works if the variable here is all by itself. You know, here it's just x all by itself in that missing spot. That works wonderfully. Actually, look at this. So 5 over 9 equals x plus 7 over 72. And I need to figure out what x is. Now, this isn't just an x here. It's not a variable all by itself there. So to avoid making mistakes, it is easiest if we do the full cross multiplication. Now, I usually do the one that has the two numbers first anyway. 5 times 72 is 360. Going this way, a little bit trickier. 9 times x plus 7 is going to look like that. 9 times x plus 7. So to put this into an equation, I have to distribute that. 9 times x plus 7 is going to be 9 times x, which is 9x. 9 times 7 is positive 63. So 9x plus 63 equals 360. From there, what am I going to do? Subtract 63. So I'm left with 9x equals 297. And then divide by 9. X equals 33. Correct? So x is 33. 33 plus 7 will be 40. So 5 over 9 equals 40 over 72. If you were very, very careful, you could cross multiply and divide here. I hesitate to show you this because it does cause a lot of mistakes.
It didn't work.
But we know this is x plus 7. I'm going to do this. I'm not finding x when I cross multiply and divide. I'm finding x plus 7 when I cross multiply and divide. So I'm going to do 5 times 72 is 360. Divide by 9 is 40. But 40 is not x. 40 is x plus 7. So, exactly. So now to solve for x, I have to subtract 7. Oops. I was getting ready to tell you the common mistake, and then I made the common mistake. So 40 minus 7 is 33. The common mistake that is made here is cross multiply and divide, I get 40. Well, it's x plus 7, so I'm going to add 7 to get 47. You got to remember, we're solving an equation here, so you got to do the opposite. You got to do the reverse. You got to take it apart. So here, find out what x is. Well, again, we're going to cross multiply. 15 times 60 is 900. Then we have 4x times 75. Well, 4 times 75 is 300, so that's 300x. So what we have is 300x equals 900. What's x got to be? Well, you divide by 300. x has to equal 3. Now again, we could have cross-multiplied and divided. 15 times 60 is 900. Divided by 75 is 12. But x doesn't equal 12. What equals 12? 4x equals 12. So to find x, we have to divide by 4. X equals 3. So we can get that answer using cross multiply and divide. We just got to be careful. Right now we're not finding x. What we're doing when we cross multiply and divide is finding 4x. Write it as an equation then and solve the equation. Oops, you get all that? Mute for a second yet? So we have 2 over y plus 7 equals 18 over 81. Find y. Tell me what y equals. So I'm going to cross multiply and solve the equation. 2 times 81 is 162. Going in this way, we have y plus 7 times 18. So I'm going to write it as 18 times y plus 7. Just because I'm more used to having the number in front of the parentheses instead of after. Then I'll distribute it. 18 times y is 18y. 18 times 7, 126. 126, perfect. So what we have here is 18y plus 126 equals 162. I'm going to subtract 126. 18y equals 36. And divide by 18. Y equals 2. Had you chosen to cross multiply and divide, 2 times 18 is 162, or 2 times 81 is 162. Divided by 18, you get 9. So y plus 7 equals 9, and then you solve that equation by subtracting 7. Like I said, this method's a little bit more difficult because there's a little bit more algebra to do. This method's a little simpler, but I found it leads to a lot more mistakes because people would go the wrong way. How many of you had y equals 2 for that one? Good deal. Let's try this. Find x. So I'm going to cross multiply. 19 times 75 is 1,425. Perfect. 5x times 95, 475x. So 475x equals 1425. Divide by 475. X equals 3. Or we could have done 19 times 75 is 1425. Divided by 95 is 15. But again, x doesn't equal 15. 5x equals 15. Divide by 5. X equals 3. Any questions? So a over 4 equals 9 over a. Find a. Not a trick question. It is possible. 4 times 9 is 36. There's nothing to divide by here, is there? So we can't do cross multiply and divide. But what's a times a? A squared. So a squared equals 36. Now we haven't really looked at equations like this, but yeah. What's been done to a is it's been squared, so we have to square root. So a would be 6. 6 squared equals 36. 6 over 4 is equal to 9 over 6. That's what that's saying. Questions? Okay. How about this one? You didn't get it? Did you understand how I got it?
Yes.
Okay. That one it might be a little more difficult than I'd ask you to do on your own, but we'll see. Let's say that you're on the job and you have 400 parts to produce. After 3 hours, you have produced 75 parts. How much longer will it take? So do we have a rate or a ratio here? We have a rate, 75 parts in 3 hours. Does it matter whether I put 3 hours over 75 parts? Say no. No, it doesn't. Good. On the other side, what do I need to put in there? Well, do I have another hour somewhere? Well, I'm asked how long. We're actually looking for the number of hours. So that's going to go on bottom, X hours. On top is parts. Do we have a number of parts? We have 400 parts. So I'm going to cross multiply and divide here. 3 times 400 is 1,200. Divided by 75 is 16. Very good. X is 16 hours. Now we have to look at this. Remember, there's relationships here. Parts to parts, hours to hours. This is parts done already in this amount of time. They're linked together. Over here, the 400 is the total number of parts. The 16 is the total number of hours. Am I looking for the total number of hours it takes? How much longer will it take? We have already done 3 hours. So yeah, we have to do 16 hours. Minus 3, there's 13 hours left. So similar to that, on a 420-mile trip, you have driven 180 miles in 3 hours. What will the total time of the trip be? I'm going to pause and let you guys figure. So similar to our last example, we have part of the whole here, which is the 180 miles in 3 hours. And again, it doesn't matter whether the 180 miles goes on top or the 3 hours goes on top. I'm used to time being on bottom, so I'm going to do 180 miles over 3 hours. On the other side, all that tells me now is that miles have to go on top and hours on bottom because they have to line up. I have the 420 miles. Well, that's going to have to go here. if I cross multiply and divide, 3 times 420 divided by 180 is 7 hours. Now the 420 miles represented the total distance, right? That means the 7 hours represents the total time. Is that what I'm looking for?
No.
Yeah. Find the total time of the trip. So 7 hours is my answer. So that's one of the things, the reason I did these last two problems like that is you do have to be very careful. Make sure that what you found is the answer to the question. The first example, you had to subtract to get the answer. The second example, that was your answer. Now the final example of proportions, it's one of my favorite examples, is this. We're going to talk about my friend Pete. Pete has a house that he's really proud of. But in his yard, he has an old elm tree that's dying. Pete wants to cut down his tree. Unfortunately, there's power lines on one side of the tree. He can't let the tree fall that way. And Pete doesn't get along so well with his neighbors on each side, so he can't have it fall to the right or the left, or get on the neighbor's property and they'll be mad. So he's got to cut the tree down and have it fall towards the house. Pete does not know how tall the tree is. He doesn't know if it's going to hit the house. He doesn't want it to hit the house. So how can he tell? Well, there's this thing that comes out every day called the sun. I know, hopefully not news to anybody. When the sun comes out, it causes the tree to cast a shadow. So Pete finds a time in the day when the shadow of the tree is in the yard where he can measure it. And he measures the shadow of the tree. It is 42 feet. And then Pete, who is exactly 6 feet tall, measures his shadow. And his shadow, at the exact same time of day, or really close to it, is 4 feet. Well, how can we use that to figure out how tall the tree is? Well, because we're looking at the ratio of height to shadow. So Pete's height is 6 feet to a shadow of 4 feet. Don't really need the feet on there because they kind of cancel out, don't they? On the other side, we don't know the height. We'll call that h, the height of the tree in feet, to a shadow of 42 feet. So to see if Pete's house is doomed, 6 times 42 is 252, and divided by 4, 63. The height of the tree is 63 feet. So now he knows that the house needs to be at least 63 feet away or the tree is going to take it out.
She said, you better get insurance.
Get insurance, just in case it's wrong. We're almost out of time. There is a new quiz due tomorrow, Friday, at 11:59 p.m. There is a new homework due Tuesday. The quiz should be open now, yes. The lab next door here is open if you want to start working on the quiz. Go back through, look in Blackboard, and make sure you don't have any missing grades. If they're not, I updated Blackboard this afternoon. So everything that was in my math lab that was due before today is in Blackboard. If you have any missing grades, we need to get on that. I will let you go back and redo quizzes since it was the beginning of the semester. If you forgot to do one or missed one, I will let you go back and redo that. Let me know and I'll reopen it for you. I'll give you a couple of days window to do them. But make sure we're staying on those. There is a new quiz pretty much after every class, the day after every class.